Sea level rise. It's a term we hear all the time, right? But it's easy to get lost in all the headlines and future predictions. So in this explainer, we're going to cut through the noise and focus on one simple question to get us started.
So let's just get right to it. Forget about forecasts for a minute. How much has the sea actually risen since the middle of the 20th century? What has already happened, according to the hard data?
And here's the answer. The global average sea level is up between 15 and 20 centimeters since 1950. To put that in perspective, that's about 6 to 8 inches. Now, that range doesn't mean scientists are guessing. It actually reflects the slightly different results you get from different but equally valid ways of measuring. And we're going to dig into how that works.
So, to really understand that number, here's our game plan. We'll start with the bottom line on the rise, then we'll look at how we actually measure the ocean. We'll get into the two main things causing it and why the graph isn't just a straight line. Then we'll cover the crucial difference between the global average and what you might see at your coast before we wrap up by tackling some common myths.
All right, so first up, the single most important takeaway here. It isn't just that the sea is rising, it's that the speed of that rise is picking up. The trend is literally accelerating. Our most precise data comes from satellites, which really came online in 1993. Back then, the sea was rising at about 2.1 millimeters per year. You fast forward to today, and that rate has shot up to about 4.5 millimeters per year. It has more than doubled in just 3 decades. That acceleration is the real story here. But how in the world do we know this? I mean, measuring the height of the entire ocean sounds impossible, right? Well, it's a massive scientific detective story, and it really comes down to two main tools that give us different but complementary pieces of the puzzle. On one side, you have tide gauges. These are basically instruments on our coastlines, and some of them have been taking notes for over 100 years, which gives us this amazing long-term historical view. The only catch? They're attached to the land, and sometimes the land itself sinks or rises. On the other side, you've got satellites. Since 1993, they've been measuring the height of the open ocean, giving us incredible global coverage. And since they're not tied to the land, they are perfect for spotting that global trend and, crucially, its acceleration. And the evolution of these tools is pretty incredible. We started with these simple tide gauges way back in the late 1800s, but the real game changer was 1993, with the launch of the first global satellites. And today, missions like Sentinel-6 are giving us this non-stop, super precise record of the whole planet's oceans. Okay, so we know the sea is rising, and we know it's getting faster. The next big question is why? Well, it really boils down to two main physical reasons, and they're both tied to a warming planet. First up is something called thermal expansion, and this is just basic physics. When you heat things up, they expand. The ocean has absorbed a staggering amount of heat, and as all that water gets warmer, it literally takes up more space. You can even try this at home. If you fill a bottle to the absolute brim with cold water and then let it warm up, some of it will spill out. That's thermal expansion, just on a planetary scale. The second driver is the melting of land ice. And this is key. This is new water being added to the bathtub, so to speak. Water that used to be locked up on land. We're talking about two main sources: all the mountain glaciers around the world, and the two absolute behemoths, the ice sheets covering Greenland and Antarctica. As they melt, that water runs into the sea and the level goes up. But what's really interesting is that the balance between these two is changing. For a long time, thermal expansion was the bigger piece of the pie. But since around the year 2000, the melt from land ice has been catching up, and fast. The melting of those huge ice sheets especially is playing a much, much bigger role than it used to. Now, if you ever look at a chart of sea level from one year to the next, you'll notice it's not a perfectly smooth, straight line. There are little bumps and dips along the way, and it's really important to understand how to separate this short-term noise from the long-term signal. Let's take the jump between 2023 and 2024. It's a perfect example. The long-term average rate of rise is about 4.5 millimeters a year. But in that 1 year, we saw a spike of almost 6 millimeters. So what happened? Well, a powerful El Niño event temporarily warmed the ocean even more, causing some extra thermal expansion. It's a textbook case of a temporary boost riding on top of that long-term trend. And that is the absolute key point to remember here. Natural cycles, things like El Niño and La Niña, they cause these year-to-year wiggles by shifting heat and water around the planet. But they don't change the fundamental direction. As this quote puts it perfectly, These bumps sit on top of the underlying upward trend.
Okay, this is a really, really important point to get. That 15 to 20 centimeter number is a global average. Think of it like the planet's average temperature. But what's happening at your specific local coastline could be very different. Sometimes it's much faster, sometimes it's even a bit slower. So why the difference? Well, it comes down to three main reasons. First, the land itself might be moving up or down. Some coastal areas are sinking, that's called subsidence, which makes the local sea level rise feel much worse. Second, you have ocean currents and wind patterns that can literally pile up water against certain coastlines. And third, you have local changes, like how sediment moves around in river deltas that can also change the shoreline.
All right, finally, let's just clear the air and talk about some common misconceptions. This is a complicated topic, so it's really easy for myths to start spreading around. Let's tackle a few by putting them side by side with the scientific facts. First myth you might hear: it's not the ocean, it's just the land sinking. Okay, here's the deal. Land sinking is a very real problem, and it makes the impacts way worse in places like the US Gulf Coast. But that's a local factor. Remember our friends, the satellites? They're measuring the height of the open ocean, far away from any coast, and they confirm the water itself is rising globally, completely independent of what the land is doing.
Myth number 2, it's all just natural cycles. This one pops up a lot, and it confuses the wiggles with the trend. Yes, as we saw, natural cycles like El Niño cause those year-to-year bumps, but they don't explain the steady, decades-long rise. And they definitely don't explain why that rise is getting faster. That long-term trend lines up perfectly with the physics of a warming ocean and melting ice. And the final myth: scientists can't even agree on the number. In reality, the scientific consensus on this is incredibly strong. The experts absolutely agree on the fundamental trend and the fact that it's accelerating. That 15 to 20 centimeter range we started with, that isn't a sign of disagreement. It's a sign of transparent, rigorous science showing the results from slightly different, well-documented methods. So let's just pull it all together. The big takeaways: global sea level has gone up by about 15 to 20 centimeters since the 1950s. Our sharpest view, which is from the satellites, shows that the rate of that rise is speeding up, now at about 4.5 millimeters per year. And maybe most importantly, you have to remember that your local experience is the sum of that global trend plus all those unique local factors. And that really brings us to our final thoughts. We've seen the global trend, and it's crystal clear. But the story of sea level rise is both global and deeply local. So the question to leave you with is, what does this trend actually look like at the coast nearest to you? Thanks for tuning in.